Okay, let me give you another applications of differential equation. Okay, this is Newton's law of cooling. This is a thermometer reading which has been at a reading of 70 degrees Fahrenheit is placed outside where the air temperature is 10 degrees Fahrenheit. Now, 3 minutes later, it is found that the thermometer reading is 25 degrees Fahrenheit. Find the thermometer reading after 6 minutes, and when will the reading be 37 degrees Fahrenheit. Now, give also a model. Okay. Now, in the Newton's law of cooling, the mathematical model in differential equation is given by this relationship. dt over dt is k T minus the temperature of the medium, where T is the temperature at any time. And uh, and then solving this is just T is equal to Tm plus C e to the kt. Okay. Notice that this can be modeled by the equation y is a e to the y equals a e to the bx. So we are going to take advantage of this particular model to solve the problem. Okay, now I'm going to use this time an emulator. Go to menu 6 and then input down and then input this model number 1. Okay, so you see you have the model here. Now you have to input 2 points. When x is 0, what is the temperature difference? The temperature difference is 70 minus 10. Difference with regards to the medium. And there must be another data here. When x is 3 minutes, the temperature difference is 25 and subtract it to 10. There. Then get the model. Let's have this model now. We want to find this A. By the way, there must be a T here. And we want to find this B. So enter option and then down. Then input number 4, that's regression. And then just input that A equals. You see I got the value of A as 60. And then to get the value of B, enter option down, then number 4, then find that B equals. So you see you get this what? You get this value already. And then insert a T. And then T minus 10 is of course the difference between the temperature and the medium. So this is now our mathematical model. Now we can solve this problem already. Okay, find the thermometer reading after 6 minutes. All you have to do is enter 6, shift 1, 5, rather 6, okay, option, and then down, and then 4, and then enter 5. Okay, that will give you the temperature difference, so you add 10. So you see your answer is 13.75. And when you get the time, when the reading is 37 degrees Fahrenheit, just input 37. Okay, 37, subtract what? 10. And then get the time, option, down, number 4. Then find that 4 there, 4 there. So you get the answer is 1.728 minutes. Now this can be done also using the 991 9570 or 991EX. Okay, let's have that calculator now. That 570 and okay 991EX. Alright, let's use this calculator now. Okay, enter mode 3. This time input the model is 5. Then input 0, when x is 0, okay, you will have the temperature difference is 60. Then after 3 minutes, you get the temperature difference is what? 25 minus 10 is 15. Okay, so you're not prepared to get the values of A and B in the mathematical model. Enter shift 1, 5, get that value of A, that is 60, and then shift 1, 5, 5, number 2, okay, you get the model B negative 0.4621. And we can also answer this. Find the thermometer reading after 6 minutes. So enter 6, shift 1, 5, and then number 5. You get the temperature difference. Just add it to 10. So you get the actual temperature. And to get the uh, time when it takes 37 degrees Fahrenheit to drop, so that 37, subtract it to what? To the temperature difference, and then shift 1, 5, get that 4, that's the time. Okay, you get that 1.728 minutes. Okay,